Let's take a look at an example now of using the trapezoid method. So we like to approximate this definite integral from negative pi over 2 to pi over 2 of cosine squared of x dx. Now this is one, and we're going to use 6 trapezoids by the way. So this is one where you do not have the abilities yet to find the antiderivative of this. So you can get really creative and then eventually you could, but at least immediately looking at this, you don't know which function has a derivative equal to cosine squared. Okay, so what does this look like then if we want to use 6 trapezoids in the trapezoid method? So this is what the curve looks like of cosine of x quantity squared on the interval negative pi over 2 to pi over 2. So we'd like to make 6 trapezoids. So basically what we're doing is we're trying to divide this whole region into 6 equal spaces. So we have these heights, we could say. So if we wanted to call this would be, say, x sub 0, this would be x sub 1, this would be x sub 2, this would be x sub 3, x sub 4, x sub 5, and x sub 6. So we have these different endpoints, but we have these 6 regions, and so what we're calculating is we're calculating this area found by these 6 trapezoids. So we find the area of each of those trapezoids, and then we're going to be done. Now, if we want to use that notation that we had before, we had to figure out what was A, what was B, what was N. Right, so if we look at this situation, our A is the starting point. That's our x sub 0 is A, but we know that's negative pi over 2. So A is negative pi over 2. B, we see is going to be equal to pi over 2. And N, we said that's the number of trapezoids that we're using. So N is going to be 6. So piecing this together, that b minus a divided by n is going to be pi over 2 plus pi over 2 divided by 6. Or in other words, this is pi over 6. So the width of each of these regions is pi over 6. So we could label these, right? Because we know that this is negative pi over 2. If I want to figure out what is this region, well then I could take negative pi over 2 and add on pi over 6, because that would be the width that I'm going over. So if we do that, I believe that will be negative pi over 3. And then this one would be negative pi over 6. This one is obviously 0. This one is pi over 6. This one is pi over 3. And this one is pi over 2. So we have all of our endpoints. We know exactly where each of these are. And now we can evaluate the height based off of the function at each of these values. So the trapezoid method. So we said the trapezoid method, this was going to be, the area was b minus a divided by 2n. And multiply this by f of x sub 0 plus 2 times f of x sub 1 plus all of these plus 2 times f of x sub n minus 1 plus f of x sub n. So I plug in everything that I know based off of this being my function. So my function, my f of x, is really cosine squared of x. So my b minus a over n was pi over 6, so b minus a over 2n is instead, if I put a 2 down here, this is going to be 2 times 6, and so this will be a 12. So I have pi over 12, and then the function x sub 0, that was going to be cosine squared of negative pi over 2. So this is cosine squared of negative pi over 2. Plus 2 times cosine squared of negative pi over 3. Negative pi over 3, we see that. Next one is going to be at negative pi over 6, plus a 2 times cosine squared of negative pi over 6, plus 2 times the next one, so we have plus 2 times cosine of 0, plus 2 times cosine of pi over 6, plus 2 times cosine of pi over 3. So I keep going on, and all of these, remember, these in the middle get used twice, except for the endpoints. These only get included once. So we have now the last point is going to be cosine squared of pi over 2. So now this forces you to have to think back to pre-calculus, remembering what are cosine of a whole bunch of these. These are all special triangles. These are, remember, pi over 2, that corresponds to 90 degrees. You could use the unit circle. Pi over 3 is going to correspond to 60 degrees, and pi over 6 is going to correspond to 30 degrees. So you can use whatever you remember to evaluate each of these. So just a brief reminder is that we do have the special triangle here. We have, say, the 30, 60, 90 right triangle. We have 1, 2, square root of 3. So we see cosine of 30 degrees, which is the same thing as cosine of pi over 6. Cosine, remember, is adjacent over hypotenuse. So we have the square root of 3 over 2. And then cosine of pi over 3, which we said was 60 degrees, that's going to be the adjacent over hypotenuse. This is going to be 1/2. So when we square these, because we're squaring cosine, we're not squaring the number on the inside. When we square this, this would become 3/4. This would become 1/4. So we have pi over 2. This is going to be 0 squared. Right? We can see that from the picture. Cosine of pi over 2 is going to be 0. We have plus 2, and then cosine of pi over 3, we said was 1/2. This is going to be 1/2 squared plus 2 times the other one, so negative square root of 3 over 2 when we square that. Square root of 3 quantity squared plus 2 cosine of 0. That's going to be the height over here. This is the height at 1. So this is going to be 1 squared plus we have 2 times the square root of 3 over 2 squared plus 2 times 1/2 squared plus 0 squared. So when we simplify all of these things, this should be a pi over 12. I forgot that pi. 12 is necessary. It's very different than 2 versus 12. All right, so once I simplify all of this, combine everything, my answer becomes pi over 2. Or you can approximate this as roughly 1.57. So the area underneath this is roughly 1.57, or in this case, we have just the clear number of pi over 2 because it simplifies very nicely. So this is what the trapezoid method looks like from start to finish. Just using this notation, just finding the function values using that formula, and hopefully that seems okay. There's nothing fancy going on here, just making sure that you're able to pull out the a, the b, the n, the function that you need, and finding the correct endpoints in our region.